There are roughly 12,500 nuclear warheads on Earth right now, spread across 9 countries, locked in silos, loaded on submarines, and mounted on missiles ready to launch in minutes. But what if, just hypothetically, we gathered every single one of them into one pile and hit the button? The answer is more terrifying than you think, and also weirdly less terrifying than you think. First, let's understand what we are working with. The world's nuclear arsenal contains about 12,500 warheads. Russia has the most, roughly 6,200. The United States comes second with about 5,400. Then China, France, the UK, Pakistan, India, Israel, and North Korea split the rest. Now, most people imagine a nuclear bomb as this city-destroying thing. And sure, some of them are. But the sizes vary wildly. The smallest tactical nukes have a yield of about 1/10 of a kiloton, enough to destroy a few city blocks. The largest, the Tsar bomber tested by the Soviet Union in 1961, had a yield of 50 megatons. That is 3,300 times more powerful than the bomb dropped on Hiroshima. If you add up the total yield of every nuclear weapon on Earth, you get roughly 5,000 megatons of TNT. That sounds like a lot. And it is, but it is also surprisingly manageable on a planetary scale. Earth gets hit with way more energy than that from the sun, every single day. Okay, so we have piled all 12,500 warheads in one spot. Let's say the middle of nowhere, the Sahara Desert. We hit the button. What happens? In the first microsecond, the temperature at ground zero reaches about 100 million degrees. That is hotter than the core of the sun. Everything within a radius of about 50 kilometers is vaporized instantly. Not destroyed, not burned, vaporized, turned into plasma. The fireball would be visible from space, a sphere of superheated plasma about 50 kilometers across, rising into the atmosphere like a second sun appearing on Earth. Astronauts on the International Space Station would see it clearly. The shockwave travels outward at supersonic speeds. Within a 200-kilometer radius, every structure is flattened. The blast wave circles the entire Earth, not once, but several times. Seismographs worldwide go haywire. It would register as roughly a magnitude 8 earthquake. Now here is where it gets globally catastrophic. The explosion launches millions of tons of dust, sand, and vaporized rock into the upper atmosphere. This debris spreads across the entire planet within weeks, and it blocks sunlight. Welcome to nuclear winter. Average global temperatures drop by 5 to 15 degrees Celsius. In summer, it feels like winter. In winter, it feels like the Ice Age. Crops fail worldwide. Not because of radiation, because there is not enough sunlight for photosynthesis. The ozone layer takes a devastating hit. Nitrogen oxides generated by the explosion destroy ozone molecules on a massive scale. For years, dangerous levels of ultraviolet radiation reach the surface. Radioactive fallout from 12,500 warheads detonated at once would be catastrophic. But here is the surprising part. It would be localized. Most of the lethal fallout would be concentrated in a zone roughly 1,000 kilometers around ground zero. Africa, the Middle East, and Southern Europe would be hit hardest, but South America, Southeast Asia, and Oceania, they would actually receive relatively low direct fallout. The real global killer is not the radiation, it is the famine. With 2 to 3 years of drastically reduced sunlight, global food production collapses by 60 to 80%. The world's 8 billion people cannot be fed. Billions starve. So here is the question everyone wants answered. Would this kill everyone? And the answer is Probably not. Humanity is incredibly hard to wipe out completely. People in the southern hemisphere, far from the blast, would survive the initial event. Underground bunkers, submarines, and remote communities would persist. Some estimates suggest 1 to 2 billion people could survive the first year, mostly in South America, Australia, New Zealand, and island nations. But survival is not thriving. The collapse of global infrastructure means no internet, no GPS, no supply chains, no modern medicine. Civilization as we know it is over. Recovery would take generations, maybe centuries. For comparison, the asteroid that killed the dinosaurs 66 million years ago delivered about 10 billion megatons of energy. That is 2 million times more than our entire nuclear arsenal. Earth recovered from that in a few million years. Our 12,500 bombs, Earth barely notices on a geological timescale. It is only devastating on a human timescale. We built these weapons to prevent war, mutually assured destruction, the idea that nobody would start a nuclear war because everyone would die. And for 75 years, it has worked. But the weapons still exist. They are still loaded. And every year, the risk of accident, miscalculation, or madness ticks up just a little bit. The doomsday clock currently sits at 90 seconds to midnight, the closest it has ever been to symbolic global catastrophe. Not because someone wants to push the button, but because in a world this complex, with this many weapons, mistakes happen. Our entire nuclear arsenal could end civilization, but not the planet. Earth would recover. Life would recover. Just not us. At least, not the version of us that exists today. And that might be the most important thing to understand about nuclear weapons. They are not a threat to the world. They are a threat to our world. If this made you think, subscribe to THEORETIKA. Next time, what would you actually see if you fell into a black hole?